Hello everyone, once again welcome to our channel Physi Dive, and this is your teacher Alex. Today we are going to study about a very important topic of class 10 NCRT, that is scattering process or scattering of light. So in this chapter we'll study this phenomenon of scattering as well as certain applications of scattering process. So without wasting time, let us dive in straight to the class. So to the class. Scattering of light. So what is this scattering of light? So scattering means once if a light rays, just imagine that light rays are here, okay, it just get interacts with particles, then it will just disperse, or we can say that it jumps into different directions after the interaction with particles, and this particular procedure is known as what? Scattering of light. Imagine that in the atmosphere there are small particles, small suspended particles like this, of different size. Okay, it is of different size, very small size. So what happens is, this light from the sun will be coming and interacting with the particles of the atmosphere. So what happens here is that they interacts with the particles suspended in the atmosphere, and then they just jumps into different direction, or what you say that it just scatters into different directions. Okay, and this particular procedure is known as scattering of light. And the scattering of light have certain applications. Okay, and we are going to study about those applications. Let us see what are those applications. So first and foremost application is the Tyndall effect. So what is the Tyndall effect? So this we can clearly see once we just go through any canopy of trees or in the morning times, while if you just get up, wake up, you can see that, just imagine that there is a window here at the upstairs of your house, and you're staying here, you're standing here, the downstairs. Suddenly the sunlight enters through this particular windows, and you can see certain path. You can see the path of sun rays entering your eyes or entering into your room. And this particular procedure of the visibility of the light path is known as what? The Tyndall effect. So if we can see the visibility of path of light is known as what? The Tyndall effect. So here, why is this Tyndall effect happening? So here also you can see that just certain suspended particles will be there. The suspended particles will be there in the atmosphere. Dust particles will be there, water molecules will be there, and other molecules will be there. And these suspended particles are very small in size. So while the sunlight enters your room, what happens there? The scattering process takes place there. Scattering process takes place there, and some of the scattered light will reach your eyes, and you can see that there is a definite path. You can see that a definite path will be there shown to your eyes, and this visibility of path of light is known as what? The Tyndall effect. And this is due to the scattering of light. This is one of the application of Tyndall, application of the scattering of light. And first and foremost is Tyndall effect. And also there are certain other applications also while studying the scattering process. And first and foremost thing is that why, if a question is asked, why the sky is blue, why the blue sky is visible to your eyes, and the only answer is that this is due to the scattering of light. So we'll discuss that thing right now. So very important question, why sky is blue in color? So you must answer this question, right? So we'll just discuss this question right now. So here in this case also, we can see that our atmosphere is filled with different particles, different particles, suspended particles, colloidal particles, and you can see that the sun rays comes, okay, I'll just use different color. Okay, the sun rays just come and just falls on this particular particle. It interacts with these particles like this. Okay, so they interact with the particles suspended in the air, atmosphere, and what happens there is they scatters into different directions. They scatters into different direction. And also, while studying the scattering process, you have to know that these particles, which particles? Suspended particles are very small in size, very small in size. So you can know that, you know that the sun, from the sun, the white light is coming forward, right? The white light is coming forward. And which light or which spectrum of the light has the least wavelength? Obviously, the blue region have the least wavelength, right? So this least wavelength regions will just interact with the small particles, and mostly the blue color will be scattered into different directions. Why? Because the other regions have higher wavelength. So what happens there? They without interaction, they will just pass out. Okay, only the blue region, which is having a least wavelength, will interact with the small particles, small size particles of these molecules, and then they scatters into different direction. And this blue region will reaches your eyes. So if you are standing here, you can see that it reaches, some of the scattered light will reaches your eyes, and it seems that the sky is blue in color. And this is only due to the scattering process. Scattering itself means that what? It's an interaction of light particles with what do you say? The particles in the suspended in the atmosphere. Okay, so this is about the answer for this question. That is why sky is blue. So why sky is blue? Because of the interaction of the blue region of light, white light, with the particles, suspended particles in the atmosphere, and those white blue light will reaches your eyes, and then you will see the blue color of the atmosphere. And just imagine that if particles are not there, if no particles are not there, then what will be the color of the sky? The answer will be black or dark. Black or dark. Why? Because there is no particle for the scattering process, so all the white light will just pass by and no light will reach us your eyes. No light will reach us your eyes means what? The sky appears to be black. That's why astronauts, while they move up, you can see that the sky, as you reach us at a higher altitude, the sky becomes darker, 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 and the complete pitch black will be there at the atmosphere. Why? Because there is no scattering process takes place there, and no light will reaches your eyes there. So that's why it seems that the atmosphere at the higher altitude seems to be darker in color. So that's it about this particular session. That is why sky is blue, and it's because of the scattering process. Here is another set of question, that is why sun appears to be red during sunrise and sunset. This is another very important question, but unfortunately this is excluded from the board exam part, but still you have to study, just study this thing. Why this reason? What is the reason for this red color, reddish color of sun during sunset and sunrise? So it's a very interesting thing. Why is it not seen blue in color? Okay, so let us see that this is Earth. Imagine that this one is Earth. And you can see that this is the horizon. I'm just drawing the horizon here. Okay, sun is here. Okay, and it seems that, okay, just imagine during morning time and sunset time, you can see the sun rays travels more. Why? Because as it enters the Earth's atmosphere, the refraction process takes place there. It refracts, bends, and then you can see it travels too long than the sun at the noon time. Sun at the noon time means it travels less. Why? Because no atmospheric refraction is there. So it travels straight line. So you can see it reaches your eyes very fast. But as you can see that the sun at the morning time and the evening time, or during sunrise and sunset, you can see the sunrise or the sun rays travels more and reaches your eyes due to the atmospheric refraction. As it travels more, you can see it interacts with the particles in the atmosphere, and the blue region will be scattered there. Why? Because the molecules are small in size and the blue region is having least wavelength. So they interact more, and the blue light will be scattered more. And as it travels more, as it travels and reaches your eyes, almost all the blue regions will be scattered out. And sunlight is a white light, and blue regions will be ruled out, and remaining that will be a red region will be available. As soon as it reaches your eyes, you can see that only most of the red regions, most of the blue regions will be scattered out, and then the remaining part is a red region of the white light. So that is why your eyes will see only the red region, and this sun appears to be very bloodish red, or you can see it's very brick red, and it's not brick red, it's actually dark red. Okay, so that is why during sunset and sunrise the sun appears to be very reddish in color. While as it in the noon time, you can see that it travels less and no scattering, not much scattering takes place there, and almost all the light reaches your eyes, and the sun appears to be almost white or a yellowish white color there. Why? Because almost all the light is reaching your eyes there. That's why the sun appears to be white. During noontime, and all the other sunset and sunrise, it appears to be dark red. Okay, this is about the sun appears to be. This is the reason why sun appears to be red during sunrise and sunset. And here also you can see that the major reason behind this causes is due to the phenomenon that is scattering of light. Now, a very important question can be asked for your board exam. Illustrate the scattering process using a laboratory technique or laboratory activity. So in that case, what will we do? Okay, let us see that laboratory activity through by which we can just illustrate the scattering process clearly. And also we can illustrate why the sky appears to be blue and why the sun is red during sunset and sunrise using this particular experiment also. So let us see what is that experiment. It's a experimental setup there. So we have to have certain materials in our hands. First and foremost thing is that 2 liters of water is required in a beaker. 2 liters of water. And second one is that 200 gram of thiosulfate, or we call it as hypo. So 200 gram of hypo is required for this particular experiment, and also 2 to 5 milli of concentrated sulfuric acid should be there in our hands. And the experimental setup is shown in the figure, and you have a source of light there and also a lens there and a beaker consisting of this particular water, 200 gram of water. Okay, then you can see a cardboard there with a hole, there at this side. You can see a hole there, and then you have a second lens there, and then a screen is placed there. Now we are going to set up this particular experiment in such a way. Now we already have everything in our hands, and the experimental setup is like this. So what we are going to do is that you fill the complete beaker with water, 200 gram of water. Okay, it is like this. Okay, it's completely filled. Now you just switch on the source. Suddenly you can see that the light rays will go and reaches this particular lens L1 there, and as it is, the source is kept at the focus. Almost all the lines or rays of light are going parallel through the beaker of water. Now you observe the beaker, you can see that no light, no path is shown in the beaker. Why? Because the scattering process or the Tyndall effect is not taking place there, because there is no molecules in this particular water right now. And the light reaches there and you will not see anything in the other side. What you have to do is that you just add 200 gram of thiosulfate into this particular beaker. Okay, beaker of water. So now your beaker consists of water and thiosulfate right now. And then what you have to do is that just add 2 to 5 milli of concentrated sulfuric acid. So 2 to 5 milli of sulfuric acid is added. So suddenly the reaction takes place there, and small sulfur particles will start to suspend on this particular water, and a colloid solution will be formed there. So suddenly the reaction takes place there, and the sulfate particles will be suspended in this particular beaker. So very nice to see that suddenly the scattering process starts there. Why? Because from the source, the white light will move there and it reaches, and the blue region of the white light will interact with the particles there, and the scattering process takes place there. And if you see the beaker, you can see that bluish color is just what moving out or coming out from this particular water part. It's very nice to see this particular experiment, and the blue region will be there. And this is one of the explanation for why sky is appearing as blue. Why? If you see the beaker right now, it appears to be blue in color. So this is the actual reason for why sky is blue. We have already seen this thing. Why? Because this blue region will reaches our eyes, and it seems that this water beaker is what do you say? It is bluish in color there. And then you can see that the other part of the screen, then through this cardboard, this hole of the cardboard, you can see some of the particles will be cut down, and the certain light rays will reach as the other lens, and then it will be focused at one point on the screen. And while you observe the screen, you can see that a reddish color, this reddish color is formed there. Why? Because almost all the blue region, almost all the blue light will be scattered out, and the remaining is what? The red color will be is remaining, and then that will be shown in this particular screen. And this is another explanation for the second part of the scattering, which we had studied right now. That is why sun is appearing as reddish in color. Why? Because almost all the blue regions will be scattered here, and the remaining part will be red. So this is an explanation or experimental setup to study the scattering process. So I hope that you understood the scattering process and the various procedures and various applications of the scattering process. So that's it for today's class. I hope that you understood clearly about the process of the scattering and what are the different things or what do you say, phenomena that you see in the nature due to the scattering process. It's very important. You can just expect the questions out from this particular portion, and we'll see in the next class with new very good topics and very important topics as well. And just stay tuned, give support, keep supporting us like you're supporting right now, or by your like, share, comment, and subscription. So till we meet again, it's goodbye from the Physi Dive team.